All right, so like I said, we are getting back into function notation. And so we're going to be solving equations using function notation. Now, the other day, the last class, when we used function notation, what we had was we had an x value, and then we found the y value. Today, we're going to flip that around where we are now going to have the y value, and we got to find the x. So my first example here, we'll start off with linear stuff. It's a little bit easier. Is given h of x, so that's just the name of the function, right, using function notation, h, equals 4x plus 1. Find x when h of x is equal to 9. Now remember last day when we had a number, it was inside the brackets because we had the x. But this time, what this is saying in function notation is that h of x, y, is equal to 9. So find x, all right? So that's how we're going to put that in there. So let's see. What is the value of x is what it's asking. Of x when y is equal to 9. And so all I'm going to do here to solve for x is I'm going to make that substitution. I know what h of x is, or I know what y is. It's the 4x plus 1. So where there's an h of x here, I'm just going to put what h of x is, which is 4x plus 1. And it equals 9. And now I can just solve this equation. So, okay, I'll bring the 1 over to the other side. So I got 4x plus 9 minus 1, whoops, equals 9 minus 1. All right, again, 9 minus 1 is 8. Divide both sides by a numerical coefficient. And it looks like x is 2. So on a graph, what that point would be is the x value is 2 and the y value is 9. Or in this case, because it's an equation, when y is 9, x equals 2. Or when x equals 2, y is 9, however you want to look at it. All right, so B, just trying that out again, where I have h of x is equal to negative 3. So again, all I am going to do is make a substitution here that h of x is equal to 4x plus 1 equals negative 3. All right, and again, all I do is solve for x. So I'm going to move that 1 to the other side. And just like before, changing sides, changes sign. All right, and let's see here. So this time, 4x, we got minus 3 minus 1. That's minus 4. Divide by my numerical coefficient on both sides. And it looks like my x value is going to be negative 1 in that particular case. So when my y value or my x value is negative 1, my y value is going to be negative 3. All right, so we'll step it up here, get a little harder. All right, so the next one we have, that was a linear equation that we had involved. Now we're going to get into a quadratic, which hopefully you somewhat remember from last year, but we'll see. Hopefully a little memory jogger. So this time we go example 2. Given our function here, I'm going to call it f of x this time. Again, the letter just refers to the name of the equation. Is equal to x squared plus 1x minus 12. All right, which is a linear equation because we have an x squared in it. A, what values of x make f of x equal to 0? All right, so there we go. All right, so I want to know again, we're looking at A here, and we're looking at our function is equal to 0. So in other words, our y value is 0. What is the x value that we're looking at? All right, so again, just like the last question, I'm going to substitute in for f of x because I know it's this quadratic here, x squared plus 1x minus 12. So I'm going to make that substitution. Now, again, because this is a quadratic equation, the only way to solve it is factoring. And this is something we are definitely going to get into this unit and the next. And to factor quadratics, this is more of like a little preview for you. There's a lot of different ways to teachers show this. Well, there's a couple different ways, I should say. I use what's called the chart method. I don't use decomposition. And so what I do is I put the x squared in the top left part of my chart, and I put the -12 in the other top right part of my chart. All right, now what I need to do is come up with two things that multiply to give me x squared. Now, when it's x squared, it's always going to be x and x. And again, we'll get into more factoring later on. Then I need two numbers that multiply to give me -12. Now, here's the catch, is that when I do the cross multiplying and add them together, I have to get 1x. And so two numbers that give me -12, I'm going to say -4 and 3. All right, but when I cross multiply here, I get -4x plus 3x's. That's -1x. But if I switch the sign here, now I get 4x's minus 3x's. That gives me the 1x. All right, so that now I have it factored, where I know that the one factor is x and then a +4. And the other one's x and a -3. And again, when you are solving by factoring, each piece now, I set equal to 0. So I got x plus 4 equals 0. And I have x minus 3 equals 0. And so again, because it's a quadratic, I'm going to get two answers. All right, so I take the +4, move it over to the other side. So one of my answers is x equals -4. The other answer is I take the -3 and move it over to the other side. And I get x equals 3. And so what values of x make f of x equal to 0? -4 and 3. All right, now I'm going to do another one here. Where we go B. What makes f of x equal to, I believe, 44? There we go. All right, now there's a little catch to it. Well, not a catch to this one yet, but again, to start, I'm going to make my substitution. There's f of x. I know what the function is. It is x squared plus 1x minus 12 equals 44. And once again, because I'm dealing with this f of x equation, it's a quadratic. So I'm going to have to factor it, but I cannot do it yet. You can't solve a quadratic equation in standard form unless you have a 0 on one side of the equation. You've got to have a 0. So I'm going to move that 44 over first. All right, so I got x squared plus 1x minus 12. The 44 comes over, so it's now going to be a minus 44. Again, before I factor, I have to collect these like terms here, collect our numbers. So we got x squared plus 1x minus 56, I believe, equals 0. All right, and now I can factor it. So again, I'm going to use my chart method over, we'll go up here. So my first term is x squared. That goes in my top right, or top left, sorry. My last term is -56. It goes in the top right-hand part. And again, when we have x squared, it's just x and x. When we get into more factoring, that'll change. All right, two numbers that multiply to give me -56. I believe 8 and -7. Now, when I cross multiply, let me check to make sure I get 1x here. So I got 8x minus 7x's. Yeah, that gives me 1x. All right, so again, I factor my quadratic equation. And so my one factor is x minus 7. And the other one's x plus 8. All right, and then again, setting them both equal to 0, just like I did over here. So I get x minus 7 equals 0. And I have x plus 8 equals 0. All right, and again, solving each equation, move the -7 over to the other side. So my one answer is going to be x equals 7. Move the +8 over to the other side. So my other answer is going to be x equals -8. Any questions at all? Check the chat. Nothing? Okay.
How do you do the like cross multiply? Like, how does it get to 0 or x1 or 1x?
1x, because right in this corner here, I have x times 8. So that's 8x. And then I add it to -7 times x. And that's how I get my 1x. It has to match 1x.
Okay.
It has to. Like, say over here, for instance, this is a better one just because of the numbers. If I had, it had to be 4 and -3, because there is other numbers that multiply, that multiply to give you -12, but yet don't give you, when you crisscross, don't give you the 1x. For instance, like -6 and 2 would work, right? But watch this. -6 times x is -6x, plus you got 2 times x, which is 2x. Well, that's a total of -4x. That doesn't match. So those don't work. So you have to find the numbers that do work. And we are going to get into a lot of factoring here in the next week or next 2 weeks. We're going to get into more tougher ones, but a lot of teachers teach decomposition. The chart method's way better. Works for all of them, which is always a helpful thing, not just a couple. All right, so let's see here. Example 3. Oh, where's my cleaner here? All right, so that's still a little wet. All right, example 3. Another function. This time, this one's called g of x. So we have g of x, or given g of x, equals x squared minus 3x minus 12. What value of x make g of x equal to 6? All right, so again, it looks like we got ourselves a quadratic here. All right, so yeah, try that little factoring again. All right, so again, I'm going to make my substitution. I know g of x, and it's apparently equal to 6, so there's my g of x function. So we have x squared minus 3x minus 12 equals 6. But again, because we have this x squared, it's a quadratic, so we're going to have to factor it to solve, or solve it. Either way, with solving quadratics, you've got to have a 0 on one side. So I'm going to move that 6 over. So now I have x squared minus 3x minus 12 minus 6, because the 6 came over. All right, so once again, I'm going to simplify. So I got x squared minus 3x minus 12 minus 6. Well, that's minus 18. All right, so once again, I am going to factor this. All right, so the first term, again, I put in the top left corner. Last term, I put in the top right. So again, because this is the easier ones we're doing for now until we get to the quadratics, it's x and x. X times x will give you x squared. But now I have to come up with 2 numbers to multiply to give me -18. And then when I do the crisscross and add, I get -3. So numbers I could try are like 9 and -2. 9 times x is 9x, but then I have minus 2x. Well, that's 7x. Not even close. So those aren't the numbers. Let's try 6 and -3. I have 6 times x, which is 6x, minus 3x's. That's positive 3x. I want -3x. Well, if I switch the signs, that'll work. So now I have minus 6x plus 3x's. Now I have minus 3x. All right, so when I factor this now, one of the factors is going to be x minus and a minus 6, so x minus 6. And the other one's going to be an x plus 3 equals 0. And just like I did before, I've set each piece to 0, because when you multiply two things and you equal 0, one of them's got to be 0 or they're both 0. And so move the negative 6 over to the other side. I get 6. Move the positive 3 over to the other side, and my other answer is going to be negative 3. So again, there's an example of solving function notation where we've got quadratic. All right, now I'm going to switch it up a little bit here. Example 4. Let's see here. Oh man, I missed my smartboard. All right, so example 4. So we have, example 4. If two functions involved here, so I have an f of x equals 4x plus 2, and the other function here is g of x equals negative 2x plus 14. And we want to find x when, all right, two situations. A, so this is a little bit different. We have f of x equals g of x. All right, so we want to find out what values of x make these two functions equal. Now on a graph, this means they actually have a point of intersection. That's something, again, we're going to get into later on this year. All right, but again, all I'm going to do here is make a substitution. So I know f of x, here it is. It is 4x plus 2. And I know g of x. It's negative 2x plus 14. So I make the two equations equal to each other. And now I'm just going to solve for x. So I'm going to get my x's to one side here. So I'm going to move this negative 2x over to the other side and then move this 2 back over with the other numbers. All right, so on the left-hand side here, I have 4x. The negative 2x is coming over, so it's going to be a positive 2x. I have a 14 here. I move the 2 over, so that's going to be a minus 2. All right, and let's see, put those two together, I get a 6x. And 14 minus 2 is 12. And then, of course, lastly, I'm going to divide by my numerical coefficient. All right, so divide both sides by 6. And my x is equal to 2. That's what makes those functions equal. All right, now I have a b line. All right, so b in this is saying, this is combining yesterday's, or I guess last day's note. But we're looking at when does f of x plus 1 equal g of x minus 8? All right, so I'm going to skip C here. All right, so now what this is saying, again, this is from yesterday, is f of x plus 1, I have to put in an x plus 1 in the f function wherever there's an x. And then I got to make it equal to the g function, but I'm going to replace the x with an x minus 8. All right, so it's combining the other days with today's. All right, so I'm going to make a substitution first. So again, my f function here was 4 times x plus 2. But in the f function, the function notation is telling me to put an x plus 1 in there. So I do that. Now the g equation, it's negative 2x plus 14, but it's negative 2 times x plus 14. But again, my function notation is telling me to put in x minus 8 where the x was in the g equation. There we go. All right, so now I have an equation to solve. But I'm going to do, again, the rainbow rule here first, where I have 4 times x and 4 times 1. So I'm going to have a 4x. 4 times 1 is 4. And I got this positive 2 there. So I'm just expanding. And then I have negative 2 times x, so that's negative 2x. And then I have a new negative 2 times a negative 8, which is a positive 16. And then I have my 14 hanging around there. There we go. So again, I'm just going to collect like terms. So I got a 4x plus 6 on this side. I got a negative 2x, and then 16 and 14 to go together, give me a 30. There we go. So it's getting smaller. That's good math. Anytime things get more complicated, you're probably going the wrong way. All right, but I can finish it off. I'm going to get my numbers on one side, letters on the other. So move the 6 over here, move the negative 2x over there. And so on this side, I'm going to have 4x plus 2x. And on the other side, I'll have a 30 there. And then a minus 6. All right, put my x's together. There's 6x. Put the numbers, or subtract them, I should say, get 24. And then finally, divide each by the numerical coefficient. And finally, after all that, we get x equals 4. And there we go. So the big thing here was, as opposed to the other day we were working with function notation where you had the x, you found the y. Today I've got the y, we got to find the x. So sometimes we had a combination of what we did the other day where you have to substitute in and then solve for the x. We had quadratic equations, simple one. We're going to do more complicated ones in a few days. And then just straight substitution. So doing linear ones.